Rate of change is basically this. You are given a known rate and you have to find an unknown rate. So it would be unknown rate equals to known rate or given rate multiplied by the derivative of area or volume of some sort of a structure. It can be a circle, it can be a cylinder, it can be a cone, or it can be a sphere. So that's the derivative of that derivative derivative of that particular structure. So the unknown rate is what we have to find. Another thing that you have to remember is a rate is anything by dt. So the rate of change of area is dA by dt, the rate of change of volume is dV by dt, the rate of change of radius is dr by dt, and that's it. So the information, let's look for the information. Oil drips from a leaking pipe and forms a circular pool. We need to know what type of shape it is. So it's a circle. It's a circular pool on horizontal ground. So we have a circular shape that we have to deal with, and the area of the pool is increasing. That means dA by dt at a constant rate, 30 centimeters square. So this information is given. This information is given. We can write given rate dA by dt equals to 30 centimeters square per second. So this is the given rate. Now we know this one. Now find to two significant figures the rate of increase of the radius. So that's the unknown rate. So unknown rate is dr by dt. This is something we need to find. Now we know what rate is given. We know what rate we have to find. Now we have one more information for finding the derivative. And the information for finding the derivative is that the area of the pool is 40 centimeters square. So when area is 40, we can write pi r square equals to 40. From here we can write r square equals to 40 by pi. Therefore r equals to plus minus square root. Since it's a radius, we are just taking the positive value, 40 divided by pi. So this is the radius, value of radius with which we can find the derivative. So let's start the question. So known rate dr by dt equals to given rate dA by dt multiplied by derivative. Now since we're talking about the area of a circle, the derivative can either be dA by dr, or it could be dr by dA, meaning the reciprocal of dA by dr. Since we have to find dr, it should be dr by dA. That means we need to find dr by dt. So this dA and this dA cancels off. Remember, since we are talking about the area of a circle, the derivative can only be dA by dr, but it can also be the reciprocal of dA by dr, which is dr by dA. So we can put the value in over here. So the value would be, let me write it over here, dr by dt equals to 30, since dA by dt is 30, into dr by dA. dr by dA is the reciprocal of dA by dr. Now we have to find the derivative. So the area of a circle is pi r square, where pi is a constant, pi is 3.142. So the derivative dA by dr is going to be, keep the constant here, r square has a derivative of twice r, so it would be twice pi r. So the value would be, at r equals to square root of 40 by pi, we can write dA by dr equals to 2 pi square root of 40 by pi. Now we can use the calculator to find the value of this. So it turns out, so 40 divided by pi is this, square root of this is the value of square root of 40 by pi, into 2 pi. Into 2 pi. This turns out to be 22.22. So let me write it down. 22.22. It's 22.419. So it should be 22.42. Okay. Now we have to find the actual rate. So the rate would be, hence, dr by dt equals to 30. This is the given rate, multiplied by reciprocal of dA by dr. That should be 1 by 22.42, and that turns out to be 30 divided by that, and that is 1.34. 1.34 centimeter per second. Two significant figure, so that means the answer should not be 1.34, the answer should be 1.3. That is two significant figure, 1.3. Remember, rate of change, you have to find the unknown rate when the given rate is, the rate would be given times a derivative. Rate is anything change with time. So the rate of change of volume is dV by dt. Rate of change of area is dA by dt. Rate of change of radius is dr by dt. And these are the rates. Derivative is if you differentiate some sort of a volume, usually it's in terms of radius, it would be dV by dr. If you differentiate area, it would be dA by dr, or they're reciprocal. So that is the idea behind rate of change sums. So the first thing that we have to do is a spherical balloon. So it's a sphere. It's a sphere. So volume of a sphere is 4/3 pi r cubed. Let me write it over here. So 4/3 pi r cubed. This is the volume of a sphere, and the rate of increase of its volume. So rate of increase of its volume means dV by dt is given by this. So given dV by dt equals to some constant divided by V. This information is given, and given that the radius of the balloon is this and the volume is this, we have to find dr by dt. That is the unknown rate we have to find. So all this information is given. So let's do this. First of all, unknown rate dr by dt equals to given rate dv by dt. Here the information is given, dv by dt into derivative. Now since we have to find r, dr by dt, so we can write here dr by dv. In that case, the dv cancels and we get dr by dt. So the formula for the volume of a sphere is 4/3 pi r cubed. Therefore, dv by dr is going to be 4/3 pi is a constant, so r cubed derivative is 3r square. We can simplify this as this 3 cancels, 4 pi r squared. And now we can plug in the value. So dr by dt equals to dv by dt. dv by dt is constant k divided by v, multiplied by dr by dv is the reciprocal of dv by dr. So it would be 1 by 4 pi r squared. Now we can simplify further. So k divided by v. Now v is 4/3 pi r cubed. Remember, we have to write down the answer in terms of r. So the formula for volume of a sphere is 4/3 pi r cubed multiplied by 1 by 4 pi r cubed. What we can do is we can take all the constant together. K is a constant, 4 by 3 pi is a constant, 4 pi is a constant. So we can take all the constant together. So k 4 by 3 pi multiplied 1 by 4 pi multiplied by r cubed into this is r squared, that is going to be 1 by r to the power 5. We can take all this constant as an arbitrary constant b. All this constant, these are all numbers, these are all constant. We can take it as an arbitrary constant b divided by r to the power 5. So dr by dt equals to constant divided by r to the power 5. At time t seconds, the length of the side of a cube is x. So this is a cube and the length of the sides of the cube is x, and the surface area of the cube is s, and the volume of the cube is v. So as we know that if this is a cube is a box where length, breadth, height, they're all equal. So if this is length, this is length, this is length, so volume would be L cubed, and every face is a square. So the area of one face is L square, and since there are 6 faces, altogether there are 6 faces, so we just add it up, or 6 L squared. So here every side is x, and the surface area and the cube of the cube is increasing at a rate at, so this is going to be ds by dt equals to 8 cm square per second. This information is given. Let me show you how the surface area can increase. If you think of the cube like this, and the cube can have the area being increased, that means the surface area is increasing, the volume is also increasing, or it can also decrease. And you can see that it's like a rubber balloon, and this can happen. And when this happens, the value of both the edge, which is rate of change of x, which is dx by dt, and rate of change of the surface area, rate of change of the volume, they can all increase. So let's start. So we have to find dx by dt. So we know unknown rate dx by dt equals to known rate ds by dt. We know the known rate is 8 into derivatives. The derivative is going to be dx by ds, so that ds cancels off. Usually area, surface area is given by the letter a, but here they are using the letter s. Sometimes they do it to check whether people are doing the sum from memory or they understand the concept or not. So let's start with the surface area. So surface area is 6l square. So here the side is x, so 6x squared. So the derivative would be ds divided by dx equals to 6 to the 12x. That is the derivative. Now we don't know the value of x, so we are going to have the expression, hence dx by dt equals to, now ds by dt is 8, so this is given 8 times, now dx by ds is the reciprocal of ds by dx, so this would be 1 by 12x. So if you simplify this, this cancels off, so this is going to be 4 2s are 8 and 4 3s are 12, and we have 1 by x over here. So this is the constant k. So 2 by 3 is the constant, so we can write k divided by x. So this is an arbitrary constant. In question number B, we have to find dv by dt. So let's write down the chain rule again. This is the unknown rate. This is what we have to find, dv by dt. Now the known rate we just found, dx by dt, and the derivative is going to be dv by dx. It is important to remember we have to use dx by dt, because if we use ds by dt, there is no derivative of, there is no rule connecting the surface area with the volume, so it's a good idea to connect it with the side. So here again we have volume is L cubed, meaning x cubed, so the derivative is going to be dv by dx, and this is going to be thrice x squared. Hence we can put it over here, dv by dt equals to, now dx by dt is 2 by 3 into 1 by x multiplied by dv by dx is 3x squared. So if we cancel this 3 and this 3 and this x and the other x, it would be twice x. Now we have to show, so v, we have to show twice v to the power 1 by 3. So for this particular question, what we have to do, for v equals to x cubed, therefore x equals to v to the power 1 by 3. So we are expressing x in terms of v. So again, dv by dt is going to be 2. Instead of x, we can write v to the power 1 by 3.